Welcome to EDU World Space.
So in this new problem, we have two people skating on frictionless ice. Okay, so we have two people that are skating on frictionless ice, and that just means that we're going to have to use the law of conservation of energy. The first one has a mass of 70.0 kilograms. So this is the information that's given. Has a mass of 70.0 kilograms, and they're moving with an initial velocity towards the right. So that's going to be positive of 4.00 meters per second. So they're moving this way. This is positive towards the right. And then the second skater has a mass of 65 kilograms, and they're moving in the opposite direction. So they're moving to the left, meaning that their velocity, their initial velocity, will be negative. So that just means that they're moving in the opposite direction to the fast skater. So they're skating, and so this is initial velocity of B happens to be negative 2.5 meters per second. So that's the information we're given. And then the second part of the problem, this is what happens before. And then afterwards, they're going to collide and stick together with a common velocity. So they'll collide and stick together with a common velocity. We don't know if they're going to end up going to the right or the left, but if they go to the right, that's positive. If they go to the left, that's negative. So we have a final V final common velocity for both of them when they collide with each other. So that's what we're going to be looking for. So we want to find the final common velocity when they collide with each other. Again, it's frictionless, so they're not losing. There are no losses of energy. Momentum is conserved. So law of conservation of momentum. Using the law of conservation of momentum, we get to see that the initial momentum of the system equals to the final momentum of the system. We want to solve for the final velocity, so we switch those positions of the momentum. And so we have they're sticking to each other, so it's almost like they have a common mass, so MA, MB. But the masses are different, but then you combine them together, so we have a plus. And then you have a final velocity, or you can look at them as distinct and then combine them using GCF, final velocity, as a factor. And then on the initial side, we have mass of A and then initial velocity of A plus mass of B and initial velocity of B. Okay, so we have the initial velocity of B. And so we want to solve for the final common velocity. If we solve for that, we end up getting MA, VAI, that's the momentum of the first skater, and then plus MB, VBI, and then we divide both sides by mass of A plus mass of B. So we're going to plug in the numbers. Remember, the final velocity of B, or rather the initial velocity of B, is a negative. So don't forget that part of the problem. And so when we plug in these numbers, we get MA 70.0 kilograms plus or times initial velocity of A, which is positive 4.00 meters per second. We have a minus because the initial velocity of B is a minus. Put the mass right there, and then 2.5 meters per second, and then we divide all of that by the mass of A, which is 70.0 kilograms, plus the mass of B, which is 65.0 kilograms. When you run your numbers, you end up getting, the final velocity, the common final velocity as positive 0.80 meters per second. So once again, remember that you want to keep the variables up until the end. And that helps you with not just simplifying the problem solving process, but also making sure that you make few mistakes when you're solving the problems. Okay, just make sure that you're having fewer mistakes because you're focusing more on the concepts and less on the actual numbers that go into the variables. Hope you enjoyed the video. Feel free to ask any questions, and looking forward to seeing you in the next video. Thanks and have a wonderful day. Okay, bye.